Now we will start the third session. The third session is a special session that we never did here before, and it's about intelligence, artificial intelligence, because artificial intelligence has arrived to stay. And there are a lot of tools that probably it will be very useful for us as well, especially for dummies like me, but also for people less dummy. So, and for me, it's an honor to present who will do the first part of the third session, who is Jesús Cerquides. And later we'll do a roundtable about artificial intelligence, that will be presented by some people of the Institute and also Jesús. Okay, I will start presenting Jesús Cerquides. Jesús Cerquides is the head of the Learning Systems Department at the Artificial Intelligence Research Institute from the CSIC. Previously, was a professor at the University of Barcelona and also in the Pablo Olavide University, director of technology and member of the board of intelligent software components, an associate director of the Union Bank of Switzerland. His research interests include artificial intelligence applications in education, probabilistic and causal machine learning, multi-agent systems, and democratic and AI-enhanced citizen science. He regularly serves as senior program committee member at major AI conferences and has been an associate editor of the Journal of Artificial Intelligence Research. Today he will give us a presentation about artificial intelligence for science, or how he learned to stop worrying about AI and love it. So, Jesús, thank you very much. The floor is yours.
Okay, thank you. So obviously the title of the talk it's a joke from this movie. So basically, I'm very honored to be here today because 30 years ago I was climbing up that road next to Palau Real and looking at this CSIC building and thinking, what the heck are they doing there? And I was a computer science student by the time. And now suddenly I'm here, 30 years after. Okay, quite glad. So let me start explaining a little bit where I come from. It's the Artificial Intelligence Research Institute. It's located in Bellaterra, in the campus of the Autonomous University. And I don't know if the number is exact, but it's around 81 plus minus 5 full-time researchers and engineers in mainly 3 departments. One more basic department of logic and reasoning, the department of machine learning, where I come from, and the multi-agent system department, which is the largest one. And then there is this technological development unit that helps people who are interested in applying artificial intelligence in industry with a more, the idea of transferring technology. In CSIC, I don't know if you know it, but so here that's a little bit of advertising that comes before the YouTube presentation. You have the advertisement, so this is the advertisement. In the CSIC, we have this Conexión en Inteligencia Artificial, and I don't know if this institute is part of it, but basically there are 35 institutes from CSIC who are interested in either doing research in a specific parts of artificial intelligence or applying artificial intelligence to their research fields. And what this connection does is putting them all together and trying to see if we can cross-fertilize and obtain advantages of this. So there are many different research groups and researchers that are involved. And right now, the thing is that what we have been able to accomplish and what will probably be guiding this connection in the next few years is that we got this co-fund to grab postdoc students which are going to be doing their postdoc 1 year in one institute and another year in another institute. So basically the idea is that CSIC is the only receiver of this co-fund, and it shows possibilities that when CSIC goes together and asks for money for a specific purpose, then we can get relatively large amounts of money. I mean, this will fund some 20 postdocs, so it's quite a good thing, and they are all going to be related to applications of AI in different fields. So just join us. Okay, so about a little bit about me. What do I do? My research has to do with Bayesian inference and probability theory for AI. That's like the main theme. But what I'm doing in terms of applications or projects in right now is telemonitoring marine biodiversity from space. So this project called PetriMed with the Institute of the Ciencias del Mar, the Maritime Sciences Institute, should be in English, they try to know what is they are interested in knowing the population in terms of phytoplankton. And they are, so basically what you do, you go there with the boat, you take the water, and you do the analysis. This is too expensive, and the idea is if we can do it from the satellite. So we get satellite images, and we try to predict that. So our task is moving from satellite images to phytoplankton concentration prediction. Another project which we are doing, again with the Institute de Ciencias del Mar, who has quite some effort devoted to citizen science, is trying to apply the concepts of deliberative democracy. So the idea of citizen science is involving the citizens in the production of science, usually is as slaves. That's the truth. So basically, we want them to go and do photos and do things for us, which are the scientists, which are very clever. And the idea is whether we can reverse this and let the citizens be first-class scientists and also be involved into a more in the control of the methods, in the control of the objectives of why we are doing the research. And this requires a more intense deliberation with, among the citizens and the citizens with the scientists. And what we are trying to do here is apply tools based coming from large language models to create these opportunities for deliberative democracy. So another project we are doing is understanding if the indoor air quality has an impact in health. This is with the Real Jardín Botánico. All these are European projects, and more technical one. Just it's not an application here. We are thinking about AI, progressing AI itself, is interfacing AI with humans, and there is also EEG halter. So the idea here is epileptic patients can be surprised by crisis at any time. And we are working with this company called MJN, and they are deploying something like this, actually, that I'm wearing right now, that has some electrodes and is used to monitor the status of your health and eventually used to predict a crisis so you can sit down. Because if I have a crisis right now and I fall, I could die not because I had a crisis, because the crisis will not kill you, but falling will kill you, or if you're driving or whatever, it could kill you. So basically, if you can predict it 20 seconds ahead and tell the person to stand down, that's going to be helpful. And related to what you do, what I did in the past is I studied how to, so you know the term of motif finding in transcription factor binding sites, so finding motifs, and basically there is a simple way of defining a motif as a matrix of probabilities of the different nucleotides, and what we were doing here is doing something more complex, incorporating intramotif dependencies. This was back in 2017, so I almost have forgotten half of it by now. But at some time, I did things in chemistry. And this is my most exciting project. I ran the half marathon 1 week and a half ago, and I'm planning to run the marathon in 2 weeks and a half if I don't collapse before. Okay, so let's concentrate on the subject of the talk. AI is on the rise. That's the percentage of articles that mention AI or machine learning. This is in computer science. Obviously, in computer science, we are all lost. I mean, we are all AI right now. So it's about 25%. But in all other disciplines, you see the same spike. So basically, AI is all the rage. We all want to do AI. How can we use it to do science? So what I'm going to be presenting is results from this Nature paper from September 2023, which did a survey to different scientists about what are you using AI for, what do you plan to use AI for. So basically, it's not me talking, it's 1,600 scientists from different places of the world responding what are the uses of AI. So one of the questions they were asked is, considering machine learning methods, what do you think are positive impacts of AI in research? And if you see, most of them say it provides faster ways to process data, speeds up computations, saves researchers time or money, automates data acquisition, so it's all data, data, data. If you have data, then I can do things with it. But then there are two ones which are very interesting for me. And it's, we can use it to make new discoveries, and we can use it to generate new research hypotheses. That's a slightly different, that's a different thing, okay? That's a game changer. And my thesis is that basically you can use AI in any stage of the scientific method. So if you, from observation to question to hypothesis to the craft of the experiments to the analysis of the results. Obviously, this is the part where everybody thinks that we will use AI in the analysis, but we can use it in some other parts, and that's the main idea that I want to communicate today. There are very interesting papers that explore this. One of them is this paper called On Scientific Understanding with Artificial Intelligence, which basically concentrates on how can we use AI for doing better science. And they identify 3 different dimensions. The first one is the computational microscope, what they call the computational microscope, and basically the idea there is we can use AI to get more insights from our current data. Okay, that's like the standard, let's say, use of AI. Then there is a second one, which is resource of inspiration, which is what I think it's coming. It's already happening at some places, but it's coming throughout science. And then there is the agent of understanding, and this is coming in 50 to 100 years. So basically, this is creating the automated scientist, and then we just sit down and the papers will be published as a paper mill. But this is a little bit of a too futuristic, for me, scenario. So I'm going to concentrate on the resource of inspiration, and they present several examples, A, B, C, D, E, of different things that could be helpful, but I have selected 2, which are a little bit more related to your field, I think. The first one is identifying surprises in the scientific literature. So one of the things that has changed in the recent years is that AI now can read. And by reading, it can browse through the literature. So we no longer need PhD students to do that. No, I'm joking. Basically, what this paper does is they use word embeddings. I don't know if you know what word embeddings are. So one of the things that neural networks do is they take anything and they move it to r to the power of n. So whatever you want to do, if you use a neural network, it will end up going to some place in the r to the power of n numbers, okay? So basically, when we work with language, what they do is you take all the different words. So for example, I take thermoelectric, and my neural network will place it somewhere in, let's say, for simplicity, we do R2. So it will say thermoelectric is here, okay? And then it will say, okay, this compound is also mapped somewhere. So basically, I have read. So what they did, they trained the neural network with all the different documents, papers from this field, and they wanted to identify new thermoelectric materials. So what they did is, okay, each of the words in the document go to a specific place in the real numbers, and now each of the words includes the different compounds. So this goes also somewhere. And then they said, okay, what is closer to thermoelectric in this space of representing words and basically anything that I've seen in a paper? And what happened is that if you map the ones which are closer and you represent actually the thermoelectricity of the compound, they identified that most of so basically there is a clear, the factor, what they wanted to identify, thermoelectric materials can be identified by this. But the good thing is not only this, but also that there were some materials, such as numbers, I mean, obviously the first ones are known to be thermoelectric, but there is number 326, which was not known to be thermoelectric and was identified as thermoelectric by this. So the idea or the main thing is that basically this was done by doing some automated reading of all the literature, something that nobody will be able to do because there are thousands of documents, and it's a very stupid processing of this, but it actually can help you identify that some of the materials are thermoelectric. That's an example of how you can use AI in a different way to obtain information. Another example is identifying surprising concepts by inspecting models. And what these guys did, I don't know if you know this concept of neural networks dreaming. So the idea is you train a neural network and then you start changing it, and it creates images which are somewhat realistic, somewhat a little bit weird. Okay, it's called dreaming. I mean, we have names for everything. We just find interesting things, and then we create a name which is catchy, and then we got millions from funders. That's how it works. So the idea here, so for example, if you think about these tools that you put a photo of yourself, and then you say, I want to see myself with 75 years, and then it distorts the photo and creates an image of yourself which is older or younger, depending on your age. So this is something similar. What they did is something similar, but on the lipophilicity side, let's say. So basically, they trained a network to predict the lipophilicity of a compound. I'm talking, but I'm just as the neural networks. I'm using the words. I don't know what lipophilicity is. So I hope you know that. I'm just repeating words. But they trained the network to predict lipophilicity, and then they took a compound, and they said, okay, what is the lipophilicity of this compound? And it was 1.0. So it's this compound here that started the thing. Okay, so after training to predict lipophilicity, I take this compound, I predict this lipophilicity. So this is the idea. I have the photo of this guy who wants the photo to be transformed, and I predict the age. And then I ask for a target lipophilicity. I want a compound which is similar to this one, but with a lipophilicity of -3. And what the neural network does is like reversing the process, is what it happens with the age. I want this guy with the age of I don't know, 75 years. So I take something which is similar to this phase, but is in the 75 years range. So what the neural network does is it goes down in terms of loss. So here, by this time, it's somehow finished. And it's identifying different compounds, proposing different compounds with different going down this lipophilicity levels until it finds this one. And this is like reversing the thing. I don't know what these compounds are. I cannot tell you how relevant or irrelevant this going down is, but I don't know if you catch the idea. Is this something that that it's relevant for you? Okay. So everything is fantastic. AI can help you in many ways, but there are also some problems. So in this questionnaire that they asked AI to scientists, they identify that generative AI may have negative impacts on the proliferation of misinformation, making plagiarism easier. It may bring inaccuracies into research texts. It can make it easier to fabricate or falsify research, bringing biases in, making it harder to assess student learning, and so on and so forth. So there's also a bunch of problems and bad consequences of applying AI. So how can we protect science from using AI badly? And here there is this paper from November last year that says, okay, there are 6 principles that we can use to help build trust in AI. This was proposed by the Geophysical Association in the United States. And basically it has, these are like very basic things. For researchers, we clearly need to document and report the data sets, the models, the bias, and the uncertainties. So basically be transparent with what you do. That's a very important thing. Also, intentionality. Ensure that the model that we are using and its implementation can be explained, are replicable, and are reusable. This means if we use ChatGPT, we cannot satisfy this intentionality, okay? It is not replicable. What we do with ChatGPT today can turn out into something different tomorrow if the model is retrained, and we don't have access to the previous model. We're going to say, hey, I want you to do this like ChatGPT in January 1, 2023. No, it will not happen. So then risk, considering and managing the possible risks and biases that data sets and algorithms are susceptible to. So how the thing that they change, for example, can affect the outcomes or have unintended consequences. Then ensuring inclusive research design, engage with communities at risk, and include the domain expertise. So this is for researchers. Then for organizations, also, basically what they say is we need to provide training on AI. And obviously, everyone that is proposing something they say, and you also need to respect what I say. So basically, follow the guidelines that I gave you. I'm creating these guidelines so that they are followed. Okay. So that's a little bit the ideas. But then there are some specifics. This is more on the use of, so these guidelines are more on the use of AI as a whole for science. But for LLMs, there is they are even more scary, I would say, because the kind of applications that we can envision they go deeper into the scientific processes. And there is this paper from October 2023 proposing, again, some guidelines, in this case for generative AI. And basically these guidelines, what they do is they define how the different players should play the game. Researchers, reviewers, and editors of scientific journals on one hand, LLM developers and companies on the other hand, and then research funding organizations. So it's trying to encompass the whole landscape of science and saying, hey, you need to do that, you need to do that, you need to do that, in order that generative AI, it's not like shooting or feed, basically. So in terms of researchers, reviewers, and editors of scientific journals, it establishes the need for human verification. And this can be disturbing because most of the activities that are proposed here that require human verification are activities that right now are exclusively done by humans. But we have to accept that anything that is done by a human right now, it's going to be done by a human helped by an AI in a few days, and by the AI in an automated mode in 3 years' time. So we need to identify which parts cannot be done with an unsupervised AI and need a human in the loop. And they call, for example, writing of manuscripts, evaluation of manuscripts by journal editors. The peer reviewing needs at least some human verification, the identification of research gaps, the formulation of research aims, and the developing of hypotheses. So we accept that we can use AI here, but we require human verification. Then tool independence. If we use AI for our research, we should be able, as much as possible, to change to a different tool. So for example, in the case of large language models, there are large language models such as ChatGPT. There are large language models freely available that you can use and download. And if you have a result just by using one of them, is not as well supported as if you have a result by using 2 or more of them, and you can reproduce this with different tools. This means that your result is consistent across tools. So you should not, your scientific results should not be dependent on the AI tool that you use to create it. Then another thing is at least knowing. If we cannot avoid that AI is used, at least let us acknowledge that we are using it and pre-register the use of AI. So researchers should say for which tasks in the paper they use generative AI, should acknowledge which tools, including the versions, and this is well known. I mean, anyone who has been working with software in publications, you should always say which package with version, blah, 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 blah. Then pre-register the use of generative AI in scientific research, and this has to do also with in the medical domain is especially relevant because it could have an impact on the selection of or the assignment of treatments and so on and so forth. And in the case of scientific journals, they should acknowledge their use of generative AI if they use it for peer review or for selection purposes of the different papers, and should ask reviewers explicitly to what extent did they use AI when writing the review, okay? Because we will. I mean, we are not doing it right now, but we will. So probably the most interesting thing in this paper is the proposal of an independent scientific auditing body, which, I mean, to my understanding, is some sort of like the nuclear security agency of AI. So basically, we need someone to regulate and to say, you can do this, no, this is not allowed, sorry, and you need to inform me when you do something like this. This kind of authority needs to be created and needs to be somehow accepted by the scientific community and by LLM developers and companies. So basically, they should make the details of what training data was used, what algorithms, what were the setups to the, I mean, not to the public, but the to this auditing authority. They should also share ongoing adaptations. And it's very interesting here. What they require is that this AI company should have a portal where we users can notify them of, hey, there is this bias in your tool, and then you have this traceability of, hey, I did this to correct the bias, now the bias is corrected, please recheck, and no, in a period of 6 months, the new model has incorporated this, has removed this bias. At least this, and this report needs to be accessible by, by the independent scientific auditing body. So sorry. So, and just last thing, for research funding organization, obviously, as previously, they should adhere to the living guidelines. They should obey us. That's always, when you write rules, you want people to obey them. And then they should not completely rely on generative AI tools in evaluating research funding proposals. So at least if you are going to give them money, at least some humans should have read what they are asking the money for. And then should acknowledge the use of generative AI tools for evaluating research proposals. So basically, the key idea is identify for which activities you require human intervention, and then also explain which uses are you doing of AI. That's like the general theme of these guidelines. So as a closing for this talk, AI is here to stay. It has many problems, but we are working on it. And it can boost your scientific productivity, and it can boost our scientific productivity as a society. So we cannot accept not using AI for science. We just need to understand how can we use AI for science so that it does not kill scientific truth in the process. Because what could happen is if we allow unrestricted AI access to our journals and our scientific literature, what will happen in a few years is that we will have AIs talking to AIs about what they think they are papers, and we are going to be watching it from the outside, looking like, okay. So that's what we need to control, and that's it. Thank you.
Thanks, Jesus. Now, usually we have the question time, but as we will do the roundtable, so we can, we can do the questions we have for Jesus and for the rest of the roundtable directly during the roundtable. The roundtable will be presented by Sílvia Pujals.
I will present the other members of the roundtable. So, apart from Dr. Cerquides, there will be Dr. Ramon Crehuet. So he has a PhD in chemistry for the University of Barcelona. He's a tenured scientist here at IQAC. Yeah, he is Ramon Crehuet since 2008. And nowadays he's using AI, like for instance using AlphaFold and similar tools to predict protein structure. And then we have Carla Ferrero here, and she's a biologist, a predoctoral researcher in the nanobiotechnology for diagnostics group, and she's developing her thesis in the field of clinical diagnostics, creating immunochemical tools for diagnosis of bacterial infections. So as for the knowledge of artificial intelligence, she's using some of the tools that we will talk about as a user, and she has received training from the Universitat de Barcelona on the general notions of using AI. Okay, so let's start with the, well, I am Sílvia. I think most of you know me. I have no experience in AI, but I am very curious about it, so I will be guiding the roundtable. So we will have 3 main blocks. It's not good. Okay. So we will divide the discussion in 3 sections. So the first one, that will be the longest, I think, will be how AI can help in scientific production. Then we will move to the ethic implications of it. And the last block will be about how we can use it in research, no? Especially for chemistry. So first I want to ask the public, so who is using regularly AI tools? Okay, only 1, 2, people is shy, 3, okay. So well, maybe we can start showing the periodical table of AI tools and asking our members here, which type of tools do you think people could use for scientific production of text and images and so on, which are the ones that you regularly use and you recommend the scientists here to use. Maybe Carla.
Yes, I can start. Okay, thank you for the introduction, Sílvia. I think it's a good point to start because when I first heard about artificial intelligence, it sounds like not a foe for me, but something that was like a stranger, because I thought this is something that has nothing to do with me because I'm not a specialist on that. I'm not, I don't know, a physician or a programmer or maybe an informatician. But then I started to hear about artificial intelligence in all social media, in LinkedIn, and there were like plenty of workshops, trainings. A lot of people started to say, okay, this is really useful for our work, so I become really curious about that. And that's what I performed, like a training of the University of Barcelona. And I think that a good point to start is like learning how to use text generation chatbots. Like, for example, it can be ChatGPT, or we have different ones. But the importance of that, I think, is to have a good training, because they have some limitations, some advantages, disadvantages. And for example, ChatGPT, it's the more known one, is not connected to internet. I mean, the version that is completely free, that is the 3.5, is just updated up until September 2021, I think. So all the information that has been created afterwards is not there. So I think it's really useful to know this information and to know that you can mix different AIs, yes, and use one of them for one purpose, another one to another purpose, and then I can talk a little bit about two more. We have BART, that is the one of Google. Now it's called Gemini. And it's really useful because it's directly connected to Google. So all the information you have in this search engine is connected to this chatbot. So this is quite useful for making questions. I think the answers are quite complex. And ChatGPT, for example, is very good for creating texts because the fluency or the connectors are quite good. And then another one is Bing, that is another chatbot. And you should also try it because it's quite good for references, because another chatbots use references that are not real.
Yeah, this we will touch
yes.
later.
And just to end, there is another one that in the training they recommend us to use, that was Perplexity. That is really good for references, and all the references are reliable. Maybe not all of them, but quite a lot of them are reliable. But it has some limitations and regarding the confidentiality, for example. So I think we have like to start using all of them and try to mix them for different purposes.
Okay, I have used Perplexity and I think it's really amazing because
yes.
I think it's 4.0, no? It's like it's the chat, it's similar to ChatGPT, but the paid one.
Mm-hmm.
I don't know if I am right.
I don't know if there is a subscription to Perplexity, but I have used the online free version,
free one
and it's quite well.
well.
But for looking for information and for small answers, when you want like a large test that is fluent and with good connectors and that is rich in vocabulary, I think it's better using the ChatGPT, for example.
So
okay.
how many people in the audience know about Perplexity?
very few of them. Yeah.
I don't know about Perplexity. Can you explain what it does
Well, it's similar to ChatGPT, but for me it works better because it's connected to the internet,
Yes.
so it
It's
gives
also
you
connected,
more
yes.
updated information.
But the thing is that the answers are quite short. Maybe you can ask to the chat to give like larger answers, but it gives sometimes like 2 different options, and you can choose one according to the kind of information you are asking for or that you are looking for. So it's quite interesting, I think.
So you know why they make you choose one of 2? You know why they make you choose one out of the 2?
I don't know, maybe they are not completely sure of the...
Because they need your information for training.
Yeah.
So basically, you're training the beast.
That's something I think it's really happening because the ChatGPT, for example, is evolving, no?
Yeah.
With all the questions we are asking, it learns more, no? And the responses are more complex and more rich. Yes.
In fact, that's why it's for free, no?
Yeah.
Or there's a version for free.
Yeah, and that's why some of the journals basically forbid you to put text to help you in reviewing using ChatGPT, for example. Because if you put a piece of the text and say, "Hey, provide me an intelligent answer to this," or an intelligent comment to a paper with this abstract, this goes into ChatGPT, and this is actually intellectual material of the authors, which should not be transferred automatically to ChatGPT, because then it's going to be digested by the monster, and it's going to be sent back to someone else in wherever, and that's intellectual property appropriation. So it's, I mean, it's a little bit. We have to be careful with what we do. I mean, they are free, but then we need to be careful about the legal implications of what we provide, because we are given this as reviewers. We are given a paper with a permission, without a permission to share the information, and we are sharing it, even if we are not knowingly sharing it. But we should be careful with that.
So which tools will you recommend? Which are the safer to use? Or
It depends. I mean, the thing is, it evolves quite fast, and there's a plethora of tools that are appearing. I'm myself, I'm using ChatGPT, although I know that that's giving them information. I'm also using Google Mail, and that's giving them information. So, but I will not recommend you doing that.
okay.
So, regarding tools, I mean, in terms of large language models, what would be the recommended practice is using open source large language models. They have the good thing that you can basically know what you're doing, and you can freeze the state of the large language model, and if you want to reproduce something that you did, it's going to come out the same thing again. So you gain reproducibility, which is very good. Then the bad thing is you need to have a machine to run the large language model. Nobody's going to give you the GPUs for free, because nobody's getting benefits from you using the large language model. So it's a tit for tat. Eventually, what would be interesting is that CSIC moves towards supporting these kinds of tools in-house with the sole interest of science for the CSIC, not that we use them to benefit some third-party company.
Yeah, this was one of the questions that we had, no? If the CSIC is planning to implement this, or some subscription to more like professional tools, if you know that other institutions, they have already them on house, so we are playing with disadvantage with this. Do you know about?
I mean, basically in CSIC, there's nothing that I know of. So there could be. I mean, I don't have obviously I don't have the full visibility. So I don't know if we have been trying to push towards that. And I know that that some of the directors of the Institute of the Robotica Industrial and the director of the IIA, they are working towards creating these facilities for AI for use at CSIC. But right now, I mean, we are having troubles just to pay ChatGPT-4. Because, you know, paying things in CSIC, it's extremely easy, as you can, I mean, you all have the experience of paying something with your credit card and trying to get the money back and things like that. So, it's very difficult to I mean, the thing is, we need a change of culture in terms of, this is going to go very fast. This is going to be evolving very fast. We don't know. It's not that now we say, hey, okay, you are authorized to pay ChatGPT version 4. It's that we need to move faster because we don't know what is coming next. And it's going to create a new need. And we need to move from this extremely regulated environment to a more, I mean, not unregulated, but basically where we are allowed to do things, and then we could be blamed for doing bad things, which is a shift of culture, because right now is you need to have all the permissions and all the sellos before you're allowed to spend €5. I mean, what comes out, in my case, my students are paying it from their pockets. That's unacceptable. But that's it. Enough complaining.
I want to make a short question for you, Jesus. If as an institution we are paying for the subscription of ChatGPT-4, for example, do you think that in terms of confidentiality is better than the free version, or is the same?
I do not know, but this is something that will have to be negotiated, I assume.
Because if as an institution, big institution as CSIC, we are paying for a subscription, I think it's important that our data are confidential.
Absolutely,
Yes.
absolutely. I mean, if we think about it, all the money that we get from intellectual property, from patents and so on and so forth, if we start discussing the patents with ChatGPT before, these guys of OpenAI are open, but they're not stupid. And they are not open, indeed.
Ramon, so which tools are you using, and are you using them to correct the text, to generate new texts? Which are the applications that you are using them for?
I'm using mainly ChatGPT also, only just to rephrase some things and to improve my English sometimes, or change the style, and also there's another one, it's there also that it can rephrase. Killbot, yeah,
yes.
that one is also quite nice. And I also wanted to kind of make this ecosystem of AI. One level is this one that is useful for all the society and including scientists, and some tools that are specialists for scientists but very in general. And then there would be like a second layer, which are, in my case, applications devoted to structural biology or chemistry, like AlphaFold, you all know about it. I don't know, tools to design molecules. But that would be a layer that it's much more specialized, but it's still a black box in terms of the user. So it's good to know where it came from and how it was trained, as with ChatGPT, because with all models, it's good to know how they extrapolate and where can they be used. But you don't need to understand how to build it. And then there would be a third application of AI, which is what most of us here are not trained to do, except for Jesus, for example, which is like build a new AI to solve your problem, right? Because that's another layer of complexity, and something that we may go into later, but most scientists, even the ones that are using computers frequently, as me, have been trained in a computational science that is very physics-based. So to me, transformers, recursive neural networks, autoencoders are just like buzzwords, but are not part of my language. I can share with you a lot of knowledge about, I don't know, a force field that encodes hydrogen bond terms and stacking and solvation terms, and we can talk to each other about that. But this other language is something that in most scientific training is missing, until now, at least.
Yeah, and the thing is that it's not only just the language or the tools, is the fact that how we approach the solution of problems, it's slightly different. So I'm more of a classical, let's say, computer scientist, where my idea is, okay, I get to a domain, I understand the domain, I try to reproduce this in the machine in some way. So if, as you were saying, van der Waals forces and so on, I create this physics model, and then I speed it up because I'm a very good computer scientist and I use AI to do some specifics. But right now, the thing is completely different. So it's the approach to solve a problem is, okay, give me the input, give me the output, forget about the physics, forget about the chemistry. I just predict the output based on the input. What do you want? You want a molecule that looks like this but does that? Okay, I learn how to do this. Nobody understands how it's done in the middle. I just skip all the physics. I just skip all the chemistry. I forget about everything that has been learned by humans, and I retrain a machine that basically does some undecipherable thing in the middle, but does the work. And this creates challenges in the sense of, so it raises problems from the point of view of philosophy of science, because if you think about it, the way we operated in science was, okay, prediction is foremost, but then once we know how to predict, what we want is simplicity, so we apply Occam's razor and we choose the simplest scientific theory. We are reaching a point where we are developing scientific theories nobody can understand, but are extremely precise in prediction. So we are going towards Ptolemaic predictions, where he was able to predict perfectly where the different planets were going to be, but the system was completely contorted. And then Copernicus appeared and said, okay, there's a much simpler explanation. So right now what we are doing is we are creating AIs, which are creating very weird theories that nobody can understand, but they work very well for prediction, as in the case of AlphaFold, for example. They just break the competition. Yeah. And then probably one of the works that we will have to do in the next few years is deciphering what the hell are the machines doing, because they're doing it better than us, and we are so we need to understand how they think, so that we can somehow mimic it or perfect it or simplify it.
But in these models, the input is very important, is the key, no? The parameters or the data that you feed the model with, it's key, because if not, you have bias. Or can you explain about this? How are they prepared? How you are sure that you have
in the case of AlphaFold, it's kind of paradoxical, because it was fed by all the proteins in the protein data bank, which were produced by crystallographers, but now it's killing crystallographers, because so they crave their own. Yeah, and it needs a lot of data, and in that case the data was there, but at some point it's of course that's what it's doing. No, it's substituting. It's able to create new output from the data it's learned, and if that output is correct, then you don't need to do the crystal. No, at some point, or the NMR structure. The question again is how reliable it is, or how to know how reliable it is. Yeah. No, which can be very difficult.
Okay, let's go back to the scientific production, because we move more to philosophical questions. So in peer review, I want you to have your opinion about how it will impact in peer review. Like, for instance, I have read that there is, in Frontiers, this editorial, it's using a system that it's called IIIA, that it's AI Review Assistant, that checks the papers before going to real reviewers. For instance, this is used, How do you think AI will impact in peer review?
I think that maybe for a first instance it can be useful, but then someone has to verify what the artificial intelligence has done, because maybe some mistakes or some things are escaping, or maybe the artificial intelligence, corrects things and they're correct, but scientifically they don't make sense. And maybe if there is not someone that is objective and is verifying that information, maybe something that is wrong is published. So I think it's a tool we can use, but not we can rely on it completely, and that we have to check and verify everything after using the artificial intelligence tools.
There's always a question when we, and it's very curious, when AI enters a field, then everybody starts thinking, hey, but we need to be sure that what AI is doing is correct and it's perfect and it's not making mistakes. Who cared about what current reviewers are doing? Okay, so current reviewers are doing good job sometimes, a bad job sometimes, and AI is going to do good job sometimes, it's going to do a bad job sometimes. The thing is, can it somehow remove the reviewer? Is if we make so how do we solve these things in science? We do a control randomized trial, and we test it. So that's what will need to be done if we want to know whether we should use AI reviewers or help of AI reviewers or not. We basically need to test it and test if this improves the quality of the papers with a posterior analysis. Until we do this, it's just ourselves protecting our ego. Like, hey, we do it better than the artificial intelligences, but who knows? I mean, we will need to do a scientific test in order to know what things are useful and what things are dangerous in reviewing.
But maybe we could combine both things, Like maybe AI checking more, like. What I know that is being applied right now is some automatic checking. Mm-hmm. So checking that the formats, that the references are properly done. So these kind of systematic things. This obviously we don't want to do that. So basically, let's AI do it. What we are a little bit more frightened is that it starts having his own opinions, and that especially if these opinions are different from ours, then it's shocking. But sometimes we need to accept it. We have our little communities which we cherish, and we like the papers in those communities, but they could be not significant. Even if we like them, even if we know the person that is submitting it, because it's anonymous, but we perfectly know who he is. And then these human failures can be somehow corrected by AI. And this is something that is not taken into account when AI is introduced in a field. It's always criticized, so we need to take into account that we are imperfect as humans in what we do in different ways.
So maybe using artificial intelligence is a way of being less subjective when accepting a paper, or maybe if it's related to your field, you approve one paper and not another. And this is something, that's human mistake, I think, no? So it can be like a balance between both of them?
I assume, I don't know. Basically, it happens that the same thing happens when you have applications in the medical domain, that they are, or in any other domain, that people are very reluctant, and they want to really AI they submit it to extremely strong checks which no human will pass when it's put for the same task. So basically it's, okay, so the first thing should be, let's compare. Let's compare with our current system formed by humans and with another system formed by humans plus some way of AI and see if the results are better or if we get the same results with less human effort, which is also an interesting outcome.
Also, as authors, how should we acknowledge the use of AI in papers? Because I have been checking, and most of the editorials, they don't have guidelines for that. I think it's just Elsevier, no, that is asking for some acknowledgements and so on. Do you know this will be regulated more in the future, or how?
But some you send this link when preparing the roundtable, and it
most
was.
Most of them they don't have. I think it's just Elsevier and Taylor and Francis, but most of the other editorials they don't have specific guidelines for reviewers, for authors, for editors.
Okay, so when they say known, it's that they don't have a guideline. Exactly. It's not that they forbid the use. Okay, I thought that known was that that is forbidden.
That there is no guideline, but I am not sure.
Okay.
We should revise that.
I don't know if you have it in mind, but my feeling, and maybe we can share it, is that people tend to rely more on, especially on the writing, more for proposals than for papers, because in general there's this kind of feeling that in the proposals there are some fields that are a little bit beyond what we would like to focus on, let's say. I don't know if you've shared that. And then the question that I read once was, if some of the sections can be filled by an AI, should they be present and evaluated?
I think that if you let me be, a little bit sarcastic here. So we know these large language models are able to create hallucinations. Yeah. Okay, and that's extremely useful for proposals because we as scientists, we write proposals and they are boring. They basically say, I'm going to move from whatever 0.5 better, blah blah, improving this small thing, and nobody wants to fund this. And then you submit them to ChatGPT, and it says it's going to help humanity in all different ways, and we say fantastic. I've never thought of it, and that's that I think in many cases that's a point that we as scientists are sometimes tuning down what we do, and for proposals you need a higher level of entropy in the thing that is suggested to the funding body.
We have a question or a comment?
Yes.
Sure.
Well, good morning, everyone. I have an important question, and I think it's very much related to what you were discussing, but it's a little bit around the atmosphere, but no one is actually tackling this. In machine learning, one of the challenges is always the outliers, or the extrapolation, okay? And when you deal with your field of chemistry or any other field, you can more or less detect these outliers, and you can handle them, and you can use your chemical intuition in this case to determine whether they make sense or not. But in a reviewer, as a reviewer, or when you are reviewing proposals or papers, in principle, the thing that, the reason why you are publishing this paper or doing this proposal is because it is an outlier. Because no one has done it before, so this information in principle is not available. So how do you think these sort of models can be applied in this when reviewing proposals, papers, and this type of things? Because it is actually an outlier, as I see it at least.
Somebody. So it's by using AI for judging proposals, no?
Yeah. So for instance, if you are using a language model and you are proposing something new, it should be in principle that what you are proposing is not very much associated to the field because it's new. So how can a language model know if what you are proposing is, makes sense to the field that is associated with? So I don't know if more or less the concept of the question is clear, but
yeah, and how can a reviewer?
I was going to say exactly the same.
Well, the reviewer has a training that is not associated just to how common are these two words associated. You know, a language model is based on how many times these two words are associated in plain words. A reviewer has a training.
That was true some years ago. I don't think right now it's the case with the current models. They are, I mean, they are stochastic parrots, but incredibly clever ones. So basically, I mean, I think that anything that we want to say about this will require. So eventually, one thing that we could do is we send it to the large language model. It outputs a review, and then it goes to a human, and the human says, "Bullshit, remove that one." I mean, clearly failed, and then he does the human review. Otherwise, it says, "Oh, nice point." It rejects it because this and that. And it makes full sense. So that's it. That's review passes and the paper. I mean, I support the review. The time that I spent on the review is, I don't know, 1/10 of what I would spend.
Yeah, absolutely. Yeah. So here's the human intervention again. So we agree on that, yeah.
So it's obviously, I mean, I think that, and when I presented these guidelines, you will need some human intervention just for safety reasons, so that we don't lose the control of the system. So if we remove the human from the system, then we will lose control. But then there are many things that we can rely on. I don't say that we can rely on right now, for example, at the current state of time, but it will come. It will come, and we will see more and more tools, and we will basically. For anything that we do, our first question should be: Can I get help from an AI to simplify my life in doing this, and then try it. And if we succeed, then we're going to be more efficient in our work than we were before. But yeah, absolutely. So the problem of extrapolation is there, and that's why the reviewer work is so difficult, both for human and for AIs. But just one last stupid comment is in 2021, I think, there was this paper presented of a shallow machine learning model, just taking into account the length of the titles and some stupid things more about a paper. So not even reading the paper, and the prediction quality of rejection and acceptance was 81%. So this gives us an idea of how much are we relying on peer review and what is the quality of our current peer review levels. So.
Okay, let's move to another topic about references from the literature. So I used ChatGPT like a few months ago, and it was generating fake references. I think now this is improving, but how can we trust the references that these tools are giving us?
I don't know if the payment version of ChatGPT can give you like reliable references, but Perplexity does. I mean, maybe not all of them. You have to check them. You have to check if the sources are reliable, are correct, have a real impact. But I think it's quite useful. And there are also different research engines that are also AIs. Such as, for example, Research Rabbit. Yes,
we have.
I think we have an example. Yeah. That yes, I have been using it during this week because I have heard about it this week for the first time, and I think it's quite useful because you can create like a library in which you can put some papers that are related to something you wanna look for, and it creates like this kind of network in which your papers are connected. It says the number of times that they have been cited, yes, and also the relevance of those papers, the year in which they were published, and related papers. So in this case, you can say, okay, I'm just mentioning these 4 papers, but there are some papers that are quite new that I haven't mentioned in my review or in my publication, and they could be really relevant. So it's a good tool for looking for additional material for your papers or your investigations.
Yeah, I find I was sorry. I was daydreaming about something that we've said before. Whether I'm not so, but just let me throw it to you to have your opinion. We were saying that at some point, this reviewing and writing may become kind of self-autonomous, and our feeling was that nothing new can come out of it. But at the same time, I was thinking that there are these adversarial networks that do learn from playing against itself or 2 different networks, and at the end they ended playing better than chess players or Go players. So I was thinking that maybe at the end, that's science fiction, but it's like an AI writing a proposal and another one reviewing it, and then someone telling us, now you go to the lab and do what I decided. No? Because if we think about it, contrary to the Industrial Revolution somehow, the automation in the lab can be done, but it's still much harder than the automation of the proposal writing and reviewing and so on. So this is the human part that we will probably, or you, because I'm doing computational work, but that will be hardest to substitute. So the fact that it becomes AI against AI doesn't mean that nothing new comes out of it. New things can come out of it.
Yeah, absolutely, absolutely. And then there is another thing that is that if we let the AI experiment with the world, then it will learn about the world. So if we actually let the AI submit proposals and execute them afterwards by means of us humans, then it will learn about the outcome of the proposal, and it will learn that this proposal was badly funded because it had no results and no relevant scientific results. So we will be just one wheel engine, small there. And it's better than we keep our hands valuable, because our brains, I mean, now that's obviously joking. I mean, it's a scenario, I don't know, for 1,000 years. It's not something that it's going to happen in our lifetimes, or at least in my lifetime. Some of you are younger. But
Okay, I'm getting worried now. I was worried about the references, but it's much worse than I was expecting. But well, how about using AI for image generation? I think we have an example in the next slide. I don't know if you know this polemic in the last week in Twitter. So if this is not clear for you, maybe you can go to the next slide, please, Alejandro. So they were generating an image with a tool that is called Midjourney. I have not experimented with this type of image generation tools, but yeah, it generated quite big penis and testes rat. And the second figure of the paper, it was like this. It was the JAG-STAT signaling pathway, and maybe you cannot see, well, from afar it looks fine, but if you zoom in, there are many mistakes in the text. So it was a paper, no, that all the figures and maybe the text too was AI generated, and it passed through reviewers, and then in Twitter there was the polemic, no, and now it has been retracted. So I wanted to ask you what you think about also image generation and use of these tools for
Yeah, I
for
think
writing papers.
on the one hand, it's nice to write graphical abstracts, not to write, but to design, or to journal covers, which I always struggle. In fact, I never do it when they suggest it, because I know that it won't be selected. But on the other, of course, it's how realistic you can make a gel, or this is supposed to be, or an NMR spectra, or so. Imagine that you know your protein, and you instead of doing the NMR spectra, you just ask for it and predict it.
There was a case, with Western blots, that they were generating Western blots.
Yeah, so yeah. In fact, I know that many biology journals are very strict in not manipulating, not even photoshopping any of the gels, no? But at some point, I think some of the images are very hard to distinguish from real ones, no? Because and it's quite worrying.
But there are tools to check if they have been generated.
For text, yes, but
for images,
I don't know if for images.
For text, but they don't work properly. And so basically, they are trained on a specific model, blah blah, and then as you change the AI a little bit, it will not get recognizable. I think it's very difficult, and I think that the only way to go is legislation. So basically, you need to say how this was produced. This there is another thing that is so here about generation of images. I think it's very useful. So especially if you're working in communication, when you try to create a presentation or a web page or wherever, and you need an image, you just ask Midjourney to create an image of men standing on the beach looking at the sea, and then there is a shark that is coming out, and everybody knows that the image is fake, basically, and you can put below saying, hey, this has been generated, but actually the visuals are transmitting what you want to transmit for this specific project or for this specific communication activity. And you don't have to pay large amounts of money to people who... Basically, you have the same tools where you look for the photo in a repository of photos, and then you pay someone who did create this material. And I mean, this is very, very valuable for... when you're a scientist doing some work which is not basically science, which is communicating to the public, this could be very helpful. That's my take. For doing it, for inserting things in papers, I mean, clearly you have to recognize that you have generated this. I mean, this is dishonesty otherwise. I mean, it's not a matter of the technology. It's like photoshopping an image and putting there whatever, a cancer cell, and saying, hey, look, I found it. No, this cannot be done. So it's the same. I think it's the same for any change that you do in material that you present in a paper. If you report results but you fake the results, that's academic dishonesty. So in this case, it's clear, right?
Are there questions from the audience from this blog about science production? Okay, Ramon, please.
About the fake references, I suggest that if you write the paper, you should read the references you are citing.
Yes.
Yes, and related to the images and the creation of new images with artificial intelligence, I have used Midjourney, but I think it's not that easy to use it because you have to download Discord. I don't know if there is another version, but the problem is that it becomes like collapsed because there are a lot of people using it and it's free. So when I try to ask for an image, it tells me, okay, you have to wait because there is too many people asking for new images. And when you ask for an image, very difficult to get what you want, because it's difficult to ask for the AI what you want. So a tip that in the training gives us is that you use another artificial intelligence to create the prompt, that is the text, for asking to the AI what you want. So yeah, I think it's important to mention that, because you have to do like use a mix of different artificial intelligences to get one single result. And then some of the images that it creates don't have any sense scientifically talking. I mean, it's not like a bio-render that has some basic things, or it makes sense with science. So I think that it would be useful to have like a tool like bio-render, in which you can put a prompt that is just a single text asking for you want, and then that you can modify the image that it gives you. I don't know if you know about this kind of tools available today. I have been looking for it, but I haven't found anyone, so...
No, that I know.
To make it. AI bio-render.
Yeah.
Coming soon from IQAC. You had that example, Ramon, no, about the images, about the doctor, no, that a doctor was asking. This is a good one.
Related to what Jesus was saying, and that the AI learns from us, no, and there was a nice, or an interesting, not nice, in fact, example of a doctor who was asking for a picture of a doctor, of myself. He was trying to get a picture of herself, and I am already saying something, and he got a picture of a male doctor, and then she said, no, I am a female doctor. And then she got a picture of a female doctor, young, white, and she said, no, sorry, I'm in the 50s. I am a doctor, female. And then at the end she got, yes, but I am black. And so that the defaults are what we also have as defaults, so somehow, but so that there's a very clear bias in this. I guess the text generation as well, but in the images it's very clear, no, because they've learned from our images and from our tagging of the images. And therefore, unless you really put all the keywords that you want, if you are not the standard, you will never be generated. In fact, these tools usually don't generate one image, but 20 or 10, and none of them was a mixture of the society's doctors, males, females, young, different colors and different. So it's nice how she really showed the bias in the image generation. That of course we can perpetuate if we don't really work on it.
Thank you, Ramon. We have been touching ethics all along the discussion, but let's focus now on the ethics part, no, and academic integrity. I think there are many gray areas, and this is a new tools, no, that are not well regulated. And so what do you think will come in the future? So this will be like a standard tools, and how are all the ethical implications of using AI and how it will be regulated?
So I think I myself don't have a strong opinion, but basically how they are trying to be regulated is what I presented. So people are already trying to get together, establish some guidelines, and
this institution that you were saying, no, this is not being formed yet. Who will form this institution to regulate all the?
Well, I don't know, but funding bodies could say if the project does not have the approval of this institution, and so the European Union could eventually propose that. I don't know. I mean, this is something that I don't know. United Nations. There are organizations for that. That are so. If we follow the path of the atomic energy regulation. There was a time when a consensus was found that this needed to be created, and it was created, and I think that we are more or less at the same position. And I don't know if we, I mean, thinking about again the similarity with atomic energy. At some point, we will face some Chernobyls in AI. We don't know what the effects could be. It could be that some specific president is re-elected in some country among the world leaders. It could be some other effects, but it could have really strong effects. The fact that AI has appeared and is interacting. So, if you think about this, we have been chatting about AI in research, but for the larger society, the same thing occurs. So the disintegration of truth that could happen in science could happen in society as a whole. In fact, in Twitter, as you know, if you look for information on the Israel war, you get like different sources saying completely different things with different photos, and nobody knows what it's really going on, and this could have Chernobyl effects in the society. So we need this somehow to be regulated to avoid. It's not the fact that AI is going to be acting against us in an intelligent way and destroying us because it's sending robots to kill us. It's basically that we are bad enough so that if we are given this empowering weapon, we're going to use it to destroy ourselves.
But don't you think that in a way it's even more challenging because the infrastructure to do nuclear research is really big and expensive and complex, whereas here it's much simpler, no, to have like a few tens of GPUs and a few people coding things. So it can become much harder to control, no?
Yeah, absolutely. So it's more similar to cybercrime,
yeah,
where an attacker can work with basically no support and start stealing computers from someone else's, and then doing denial of service, and then building up resources as we go. Yeah. So I don't have a solution. I'm sorry.
Okay, I was very optimistic about the use of AI, but I am getting more and more scared.
One thing that worries me also is that many times the very similar tools can be applied for very useful and positive outcomes or to generate. So very similar architectures and developments in AI can be used to produce extremely useful tools, but the same, probably it's like the atomic bomb, no? But the same architectures and developments, because there's a lot of development, I mean, can lead small changes to applications that are negative to our society or detrimental. With most technologies, it's the same, no? I think.
Are there questions from the audience on the ethical implications of AI? No? Okay, let's move to the third block. I think people is hungry, so let's go to the science and being positive. How can AI help in chemistry, in data generation, in data... So for instance, let's start with AlphaFold. I think you explained it a little bit, but maybe you can go maybe a little bit deeper, Ramon, on the use of
I think,
AlphaFold.
Well, AlphaFold has been a game changer in the prediction of structure, but in fact, people say AlphaFold, but now it has spread and reproduced, so there are many new tools to predict protein structure. Some of them have a different network architecture. In fact, some of them are based on these large language models, and they are much faster than AlphaFold and with similar precision. And you may think that doesn't really matter, but It makes a difference if it takes several minutes, which is what AlphaFold usually does, than if it takes just a few seconds, because it means that with a workstation you can generate the structures of a whole proteome of an organism. So the numbers are amazing like this. There are many things missing, like, for example, interactions with the small ligands, post-translational modifications, dynamics. But as I'm saying this, there are preprints that are already delving into that. So the new AlphaFold version will introduce protein generations together with ligands or cofactors. It will include post-translational modifications. And there's another preprint by Rosetta Fold Group, which is doing the same. So it's kind of amazing that the field is... In fact, we recently published a paper about designing a new protein, and while we were writing it, not even submitting it, the methods that we were using were outdated. And the reviewers completely understood it. I mean, it was like, if this has to be used in a lab, we have to admit that it takes time, and of course, so we cannot ask for the latest, most efficient protein design method, because then you will be just waiting to get... It's like when a few years ago, when you were wanting to buy a new PC, no? It's like, if I wait a little bit, my memory will double. If I wait a little bit, the CPU, and so I just wait and never buy it. So the field is evolving very fast. And another application that we were discussing with Sílvia about, it's also related to creativity somehow, is the possibility of generating virtual molecules, no? Similar to what Jesús said, and then there are a lot of applications, so building them inside the binding pocket of a molecule, building them with some specific lipophilicity or other Lipinski rules to make it a drug target, and so on. And then again, the way they are built is also related to how they have learned it. Because some learn from just looking at the databases, and then they generate very potentially interesting molecules, but that synthetic chemists say, oh, come on, this is impossible, or a lot of work, whereas others learn from reactions. And then, of course, they suggest things that are much more doable, maybe less original, but much more doable, because they have created the molecule by virtually doing the synthesis of it.
Also for synthetic routes, no? You were saying that
there's also some tools which I haven't tried because I don't know enough synthetic chemistry that can do the retrosynthesis of some molecule. So you say, I want this, how would I synthesize it? And I'm not sure how good they are, so it would be interesting to check.
So I think we were discussing, no, about this creativity of AI. I would like to know your opinion. For me, I don't know, I was optimistic and I was thinking humans are more creative than AI, but Ramon was...
but that's being pessimistic.
So how can it be creative?
No,
if it's trained with data that it's already there, and I don't understand how.
Basically, so the way it is creative is very stupid. It's random, as we are creative, probably. So basically, it's by doing random things and then selecting these random things which make more sense. If you have a way of understanding what makes sense, what is relatively nice, for example, you can create random images and then select one that is nice. And actually, this has been proven by some experiments that, well, basically, that you could do this without thinking about it by a community of people. So you could do this without having a proper intelligence generating the image, just people selecting one or the other, and like millions of people doing it together. And you evolve a picture which is really nice just by random selection by different sets of people. So basically, the way that I think, or one tool that I think could be very interesting is, as scientists, we know that it is very important to discuss your ideas with colleagues. So if we accept one well-trained large language model with knowledge about the bibliography and that has read all of the chemistry books and has digested them, and we start discussing our research ideas with it, in this interchange, it will raise points that we haven't seen, as will any colleague, and it will provide us with probably with ideas if we request it, because it's far more open than other colleagues, which are going to keep their best ideas for themselves. So basically, it's going to be honest. It's going to give you new research ideas, of which you can obviously remove, I don't know, 99%, but you can actually be illuminated by a 1%. And this, it's an extremely valuable resource. And you only spend, I don't know, one evening chatting with the thing. So I don't know if this thing, at the level that it can be useful to you, exists nowadays. But I'm envisioning that this will exist at some point. Right now, when I try to do it with ChatGPT, it works to a certain level. Once you get too technical, into the details, into the nitty-gritties of the research, then it's the intelligence there is too shallow. Even though, I mean, the good thing is that it's connecting many things. I mean, you as chemists are used to talk to other chemists. Sometimes if you talk to a, I don't know, particle physicist, it will tell you, no, but look, there is this thing, which is, I understand, completely different. So ChatGPT can play also a little bit this role, because it knows a little bit more of everything, but it doesn't know as much as you do about chemistry. But if in the future it is specialized and the thing improves, it could be a very good partner to discuss with and to obtain ideas.
But those ideas will be radically different? Can it give you a radically different solution?
It's more, can it help me find a radically different idea? Mm-hmm. It's not that ChatGPT will give you a result to your prompt. So after you start a discussion, you will see, no, that's not what I want. I want something different. I want this, but in the domain of, I don't know, whatever, narcogenesis, blah, blah, blah. So, and then it will rephrase, and you will say, no, this is not again, I want it connected to this result that was found yesterday. And and in this discussion, it will find out, it could find out something that is valuable to you. But it's not that ChatGPT is going to understand by the first time you give the question is going to provide you perfectly. Hey, you need to do this. No, it's more like you need to press it a little bit. It's like a PhD student, you know. You need to.
Okay, so I think it's a way of getting new ideas that maybe you can. By yourself, you are not going to find out, okay? But if you find out something that is interesting, for example, for some specific application or for drug discovery or something related, do you think that it could be confidential, or if anyone else can take your idea? Because, I don't know, what you have created then is confidential, or has anyone access to that information?
It depends on which AI you discuss with. Okay. And so you need to be careful. What are the rights? So these terms of use, which we always say yes and forget about it, they are doing something. They have something written there. So we need to be careful what we use. And this goes again to CSIC creating the AI that is not leaking information somewhere else.
We were discussing, Ramon, also not only about creativity, about being innovative, no? And this, you had your doubts about.
Yeah, one thing that I think it's curious is that all this ChatGPT as an example of these AIs, that they are very willing to help all the time, but so far, at least, they show no interest. So they do learn a lot. They do learn from what you ask. But they never ask questions, no? They show no interest in getting feedback. And in that sense, we thought that we were still more creative, because in a way we are asking the questions towards the answer that we are looking for. No, in a way, it's fortunately, or I don't know, it's never the other way around. No, that he's saying no, wait. You're talking about this, but I think this is much more interesting. And I think, why have you tried this, or have you? You know what I mean? That we still in this. So when you open the chat, the prompt is yours. It's not his prompt saying, "Hello, I was waiting for you, and I wanted to ask you this thing." No. So, well, at least we keep the initiative so far.
But this is because we will not accept the other way. I mean, at OpenAI, they will be extremely happy if they could have the conversation the other way around, with the AI asking the questions and you answering them. That's ideal.
For them, yeah.
But then nobody would be interested in playing this game. So.
Let's open the discussion to the public. Come on, questions on any topic? No? They are not very motivated either. I think, okay, so, thank you, Sergi.
So, how would you define creativity in like scientific terms, or like how would you define it in a way that an AI can learn to be creative?
I am completely not qualified to answer this question.
So what is a creative solution? A rather non-common solution that also works? Is that creativity?
So I will say that I don't know how to define creativity properly, but I will say that it basically has a component of novelty, right? It has to be I mean, it could come at different levels. So if you think about music creativity, it's basically, you could have a new theme, a new song, and this could be creative. It could be very similar to someone else's song, and then it's not so creative. It could be opening a whole new musical style. That's extremely creative.
That's rare, more than creative. Would you really say something new is automatically creative?
Not something new is. I don't think something new is automatically created. Something new that raises interest and somehow that is valuable in whatever field, that should be acknowledged as creative. So if I come up with a new chemistry idea, but it's bogus, then it is. I mean, you could say it's creative, but it's not that much interest. But if I come with a new idea which actually has an impact, which is actually able to change the views of people and to create a new perspective, that is creative. I mean, I'm just trying to find out the definition as we speak. So basically, this is extremely inaccurate and wrong. But
I think this is very important particularly for generative models, because you need to give the model like which tools can it use to create new molecules or things like that. So it has to know what is a chemical modification that makes sense, but at the same time that is creative. So it has to be new, but doable at the same time. So this, I guess there is a different definition in any field, but it's very important to define or to know or to teach the model what is a creative solution that will make sense and that will work. But I think this is a very complex issue, I think.
So I think that if you think about it, what you need to define is some sort of the value of something new. because I can't generate new things randomly. And I mean, if I'm clever, I can generate new things randomly, which are close to a good interest number, let's say. So what I really have to teach is what is interesting, what are the interests of this community. I'm generating objects, let it be ideas, papers, whatever, and I have this interested community in receiving these objects. What is interesting to them? And then I start generating things randomly, and I select the ones which are better in this interest level, and I provide them to you, and you say, hey, out of these ones, 99% are bogus, but this one is actually interesting. And then you tell me, this is interesting, and then the AI says, hey, I changed my definition of interesting, and I update it, and next time I'm going to keep providing more interesting things.
Empiezo de nuevo. Creativity is defined as the tendency to generate or recognize ideas, alternatives, or possibilities that may be useful in solving problems, communicating with others, and entertaining ourselves and others.
If we go back to the molecules example, I think it's a very open question, no? Because I think it has been estimated that the number of small molecule, the number of small molecules that potentially can be, or that can exist, it's about 10 to the 90, something like that, which is more than the atoms in the universe. And another question is which ones are synthetically accessible, and probably another question is synthetically accessible within a reasonable framework of time and money. But that doesn't mean that there is one of the suggested molecules that an AI could generate is maybe the cure for the cancer. No, the problem is how to find out if that's really the true cure if we cannot even synthesize it. No, but with proteins, something similar has happened. The protein design algorithms, the first ones, designed structures that in theory they were predicted to be stable and close to the target structures, but they were not expressible in cells for whatever reason, because cells tend to have a machinery that works. In theory, we know that each ribosome will read a sequence and generate will read the codon and find for the right amino acid and so on. But in practice, you know much better than me that if some codons are repeated many times, then it runs out of that amino acid and so on. And then some proteins don't express. And the generated proteins at the beginning were so original that they didn't express, most of them. And now it has learned to do things that are more natural-like. So that now you tell them to express them, and in a high rate, you really can get that protein. It's soluble, you can isolate it, and so on. So it's less creative, but it's more efficient.
Okay, maybe one last question from the audience? No? Okay, Gemma, please.
Apply it to chemistry, biology. I think one important thing that we should have in mind is that they need to have access to data, no? That not only positive data but also negative ones. So, because they need to learn, no? But it's not so easy to have access to all this data. And so now projects are asking us to give raw data, to give access to all this data, but I don't know how this will be handled and how this can be useful to train artificial intelligence to get to conclusions, no? To get to some decisions.
This is fundamental. I was thinking about it while I was seeing the presentation of the different technological services. I was seeing data. So I don't know if this is something doable. I have no idea how they are run, but you have a wealth of data there of all the analysis that you do, and it would be interesting that this data is not lost, basically, that it's adequately stored, and because it will be interesting at some point for training for specific purposes. So knowing how the different spectrograms from different molecules look like and so on and so forth, and storing thousands of them. I mean, I know someone will kill me because they were complaining that they occupy too much hard disk, but this is very, very valuable for future research.
Okay, if there are no more comments, I think everybody has a lot of food for thought. Now we want food for the stomach. So I want to thank all the members of the Roundtable for giving their nice opinions.